So I'm looking in your notes on page 11. We can use your calculator to calculate this rather than that formula. The formula is necessary for showing your work, especially for simple single value binomial probability formula applications, but it is much more efficient, especially if you're doing multiple, to use the next thing I'm about to show you. So, yeah, I'm sorry, got distracted. So there are two different commands in your calculator. This is both for the 83s, the 84s, and the Inspires. It is also true for the Casios, but I don't have one of those to play with, so again, I'm no help for you, I apologize. But regardless, I'm fairly certain all of these calculators have these two functions just in different locations. And the inputs for these commands, everybody is going to need the number of trials because binomials always have a set number of trials. We will need to know our success of a probability on any one trial because, again, that's another hallmark of binomial probabilities. And then the values of interest for the variable x. Now that changes. If the random variable x, I'm looking for just a single value. So I'm using random variable capital X if it's saying that it is equal to x. My example for this is A that we did in class here. We just found the probability of a single, of 3 children with type O blood. So of the 5, finding 3 of them. We used our formula in class, that's fine, but the calculator can and will calculate this with the binom PDF function. So I could have alternately found the exact same answer, and I know you have stuff written here. I'll do another example in a second that you can write down. Using my calculator's binom PDF. Now I am going to be showing the TI-84 and how it works, but the Inspire, I will also post these directions so that you can see the commands that you need to follow on your calculator to do this exact same thing. So you're going to see that you still need the number of trials, the number of successes, and the X value in question, but again, it's just going to look different as I actually type it in. So my calculator will need to know what is in, so 5 kids. What is X? We want 3 successes, 3 type O bloods. That's not what comes next. P comes next. I'm just following through these values here, N, P, and X. So N was 5. The probability of success is 0.25. And I'm looking to calculate just a single value of 3. So I'm going to be putting this in my calculator. I'm going to attempt to make you nauseous first, and then show you in my calculator, which is running out of batteries. So I need to push my distribution button here. So second distribution. Hopefully we can see that. I think that was helpful. So we're going to use a whole lot of this. Mine is option A. Yours might be slightly different, but it should say binom PDF. CDF will be used shortly. PDF is right above it. Yours, especially if you have an 83 or an older operating 84, you might not see these prompts, but we all need to put in again that there are 5 trials, 25% chance of success, and we want 3 successes. If you don't have these trials P and X value, you will just need to put a 5, 0.25, 3, and the comma is right above the 7. So when I hit enter, I get the same thing that we got in class when we use the actual formula to calculate it. So it's not like it's any different, and it's also not like you can show what I just wrote down here as your work. This is calculator speak, and on the AP test, not considered sufficient. But you might prefer to actually using your calculator to find all that and type all that in. So that is if X is equal to a single value. If you're trying to calculate for your, that's not what I meant to do, for your random variable being less than or equal to a single value, that's when you want C, because C is standing for cumulative. So we've talked about cumulative before, where I'm wanting starting at your senior year and all the years before it. So starting at this X value and all the X values before it. The thing is, on part B, it was more than 3. So if I think of all the values my random variable X can be, so I can have 0 kids with type O blood, I can have 5 kids with type O blood. This is asking for us to calculate more than 3. We can use our calculator to find all the ones I don't want, because the calculator is very adept at finding starting in an X value and all the values before it. So if I wanted to use my calculator, I would be using the cumulative function with, again, 5 trials, 25% chance success. But if I calculate an x value of 3, this is telling my calculator, okay, go ahead and find the probability that it's 3, but also find 2 and 1 and 0 and sum all of those for me. These are all the outcomes I don't want. So we would be finding the complement. If you ever want more than, so I could say down here, if you take the complement of a binom CDF of n, p, x, this is finding the probability that x is, I should use a capital X, that my random variable x is larger than the x value I put in. And there's a slight typo here because I technically shouldn't use x for both of these, but whatever, I'm gonna give you more practice on this. But if I put that in my calculator, I will get the same result as I got on part B, and it will be more efficient than doing 2 binomial probability formulas. Again, it's not sufficient work to not show that, but it is quicker when you just want the answer. So I am doing the complement, so, oh no. Okay, I thought my batteries were finally low enough I couldn't show you this. So 1 minus, I'm gonna just scroll up to get to binom CDF, I'm finding cumulative. Pretty much any time you would like your calculator to add some values for you, it's going to be quicker to use CDF than to actually find the individual probabilities and add them manually. But again, we see what we got in class. So there is a note on here, like I already said, don't rely on calculator speak when showing your work. That will not earn you full credit for a calculation. At the very least, you have to include what those inputs represent. So not even putting in, but writing out, there are 5 trials. This is my probability of success. It is much better to do what we did in class where I'm showing that I'm putting my formula. I know what my binomial formula is, and then you can use your calculator to just calculate it. So when you find binomial probabilities, there's a process that you should be doing. First of all, you need to state the distribution you're about to use. So far, binomial is all we know, but we will eventually get others. So you will state the formula you're about to use, the binomial distribution. You will state values of interest. So you specify the binomial distribution with number of trials n, probability of success p, and the values of the variable clearly identified. Then you're going to perform your calculations showing your work. So again, I've said this multiple times already, so using the probability formula or using your calculator but actually labeling it so it's not just the calculator speak. So I'm going to go through an example of how I want this done. A local fast food restaurant's running a draw 3 get it free lunch program. After each customer orders a touchscreen display shows the message, press here to win a free lunch. A computer program then simulates one card being drawn from a standard deck. If the chosen card is a 3, the customer's order is free. Otherwise, the customer must pay the bill. On the first day of the promotion, 250 customers place lunch order. We're going to find the probability that fewer than 10 of them will win a free lunch. So the first thing I'm going to do is I'm going to let Y be the number of customers who win a free lunch. And I'm sorry I didn't give you a ton of space for work here. Now, this is a binomial setting. So I'm just going to put Y is a binomial variable distribution. Not entirely convinced that I have the right terminology here, but I'm just going to say my number of trials, so winning a free lunch, this is going to be possibly happening up to 250 times because there are 250 customers that day. I need the probability of success, and again, this is from a deck of cards. There are 52 cards in a standard deck, and it says if the card is a 3, there are 4 3s in a deck of cards. The 3 of hearts, 3 of spades, 3 of diamonds, 3 of clubs. So 4 out of 52. And then the values of the variable clearly defined. Now, Y can take on lots of values. When it's binomial, you could have no successes, or 1 success, or all the way until n successes. It is unlikely, but theoretically possible to have 250 winners that day. So I'm listing them all out. It's wanting the probability of fewer than 10. So I'm just going to write out, I'm finding the probability that my random variable y is less than 10. So some of us need a bit of review over those symbols. That is the less than symbol because when you read left to right, you're getting the small side first. So it's less than 10. The numbers on my list that are less than 10 are 0, 1, and 2, all the way up to 9. So I want 9 and below. First of all, I'm saying multiple random variables, multiple y values. So I'm not going to use PDF because that only finds one at a time. I'm going to use CDF. Because I'm doing the probability of 0 plus the probability of 1 plus 2 plus 3, I could show my formula and sum them together. Even using dot, dot, dots, though, it's not super efficient. So again, I'm finding the probability that my random variable y is less than or equal to 9. So I will be using CDF. I will not be doing a complement. Complements are when you want above. So remember, C stands for cumulative. This is like 9th grade GPA all the way through pre-kindergarten, which wouldn't make sense, but that is kind of what we're representing. I don't want to go above it. So I will be putting in that we have 250 trials, which I know is written out elsewhere, but this is still proper form for how you should write these out. 4 out of 52 chance of success on each individual trial. And the X value that I will be putting in is the 9 and not the 10. Because again, your calculator will start at the value you put in and add all the previous values. And since I want to be less than 10, not include 10, I will include 9. And when I put that in my calculator, I get a very small probability. It is not very likely that I would get less than 10 winners. So on page 12, oh, hey, turns out only 9 customers won a free lunch. So something less than 10 happened. We can use these results to kind of interpret how likely this should be. So does this give convincing evidence that the computer program is flawed? Now you're probably going to want to pause to write some of this down because I already wrote mine down. But there is a very small probability that fewer than 10 customers should win, assuming the program is working. So basically, something very unlikely has happened. Only 9 customers won. There was 0.6% chance that that happened. Because this is so unlikely, because only 9 customers won, we have convincing evidence that the program is flawed. This should not happen, is basically what we're seeing. So sometimes you're going to get this question of, does this give you evidence of things? And it is really similar to some of the reasoning that we had second semester. So I know this video is already really long, but I do want to go over 2 more to give you practice on just calculating this. So to introduce his class to binomial distributions, Mr. Miller's class takes the same pop quiz that you did in class. Hannah is one of the students in this class, and X is the number of questions that Hannah answers correctly. We're going to use the binomial probability formula to find the probability that X equals 3, and then we will interpret this result. So we've already talked about showing that this is a binomial setting. So I'm just going to practice. First of all, I'm writing the probability that X is 3. If you are using the formula, which you can, when it's a single value, it is not terribly difficult to do this. So remember, I'm showing this combination of 10, selecting 3 of those 10. And then I would say the probability of success, I would want 3 successes. So I would then have 7 failures. That is the same, if you would like to practice the calculator, as using PDF, because there is a single X value I'm trying to calculate. You would then just have to write out that in this scenario, you have 10 trials, you would have a probability of success of 20%, and the only X value we are trying to calculate is 3. These are considered equivalent and both sufficient work on their own. You do not need to have both. You might want to check that you are capable of successfully calculating that it should be 20.13%. Now, I'm not going to write out the interpretation of the results because, again, this video is longer than I wanted it to be. But it's that there's about a 20% chance that Hannah answers exactly 3 questions correctly. So to get a passing score on the quiz, the student must answer at least 6 questions correctly. Would you be surprised if Hannah earned a passing score? So let's find the probability that this would happen to somebody. So in my notation, at least 6. So if I told you, you got to get at least 6 right, getting 5 right will not cut it. But you could get 6 right. So it could be equal to 6, or it could be something more than 6. So at least does not mean less than. It's greater than or equal to. So when I do this, I could go ahead and write out that I'm going to find the probability that x is 6 plus the probability that x is 7 plus the probability that x is 8, all the way up to 10. It is more efficient to use our calculator because, let me write out everything x can be. Binomials always start at having 0 successes, and it always ends at your number of trials. We are trying to find at least 6 successes. These are the outcomes we want. And because I am too lazy to add them individually, it is much quicker to just take away what I don't want. So I'm going to do the complement of the probability that my random variable x is less than or equal to 5. So I'm finding the probability that it's less than 6 and taking those away. So when you try to find less than or equal to, your calculator uses CDF really well. And as I'm saying this, I'm just now remembering, I'm pretty sure the Inspires and possibly the Casios, I think you can just set an upper value. It might ask you lower and upper. I don't remember, correct me if I'm wrong, but you might not have to do all this complement business, which I am jealous about. You might just be able to say lower is 6, upper is 10, calculate. Try that out and see if it works if you have that type of calculator. The rest of us, we're going to note that we have 10 trials, 20% chance of success on any one trial, and the x value, there are multiple x values that it's going to calculate because I'm using a cumulative function, but the very highest one I'm going to include would be the 5. I'm taking 5 and below out. So this red that I highlighted here, that is being calculated here. That is being calculated here. I'm taking that away so that I'm left with my yellow. I'm left with 6 on up. So check your calculator, check your ability to type this in. You should get 0.0064, which is really unlikely. So there's only a 0.0064 chance of passing, so we should be very surprised if Hannah passes. Honestly, if any one of you said, oh yeah, I passed that quiz, I kind of would just assume you're lying because it's so unlikely that any of you would guess those correct, that would guess 6 or more correct when we are